speaker, many of you know him, really, researcher, Francesco Sarracino, which is based now in Luxembourg, Statistical Office of Luxembourg, and University of Louvain de La Neuve. Yeah, good. So, okay, with the talk estimation error due to duplicated observation and Monte Carlo Simulation, the floor is yours. 40 minutes, something like that.
Thank you very much. Thank you very much, and thanks a lot to all of you for making it till the last session of this long day. I know it's you're tired and probably you're already thinking about the evening, so I hope I managed to give you good value for money. And as this is for free, it shouldn't be difficult, right? I'm very happy and honored to share with you the results of a recent work I've done together with Magda Mikuska, who doesn't need any introduction. Actually, she is from the University of Louvain. I am just from the statistical office, but both of us are happy and bright affiliates of the Laboratory for Comparative Research. So, as I'm going to speak for probably the next 30-40 minutes, I would like to start by first hearing your voice. And therefore, I would like to ask you a question. How many of you base their work on the use of survey data? 1, 2, 3, 4. Okay, I would say we're approximating 100%, right? So you probably all know or don't need to know how important it is to have good quality data at our hands. How much do you worry about missing data? How much do you worry about scales of different variables, comparability of variables, order of wordings in questionnaires, etc. What else? Have I forgot something relevant?
Attrition.
Sorry?
Attrition, what the name was?
Attrition, yes, in panel data, attrition is a problem. So today I'm here to speak about everything but not what I just mentioned. I'm here to speak about a problem that is often neglected in social sciences. And this is duplicated data, the presence of duplicated data in surveys. And in particular, what I'm interested in is how the presence of duplicate observations in random samples affect our estimates. The first thing you do when you have a research question is you browse the literature. That's what Gosh and me did. And to sum up the literature we found on this topic, I just need one slide, because the answer is this one. The literature neglects the problem of duplicate data in our survey analysis. We have checked economic literature, sociological literature, political science, methodology, statistics, and applied psychological literature. We didn't find any paper dealing with the issue of how non-unique observations in survey data affects our estimations. This is a rare case when the literature really shuts up on a topic. And this, of course, rings a bell. The cases are two. Either this is a very stupid and bad question, or this is a very good one. That's why we decided to look deeper into the literature and try to figure better what are the issues at stake. So, what is that we're talking about? This we know. Duplicate records are records that are not unique. La Palessiana. Records in which the set of all, or nearly all, answers from a given respondent is identical to that of another respondent. To make it very simple, imagine you have a simple matrix of data, you have one observation, that one observation is entirely copy-pasted, n times. This is a duplicated record. Sometimes, not necessarily all the information from one respondent are duplicated 2 or more times. Sometimes only some of them are duplicated. And this is what we call near duplicates. You say, all right, why would this be a duplicate? Well, because sometimes someone who wants to copy observations, to say, let's say time, would just copy the majority of variable, but not those that identify strata. Why? Because otherwise, if they copy also the strata, the design would not work anymore, and an eventual fraud would be easily spotted out. Now, probably you share Anna's concern. She shared with me beforehand, so I'm thankful I have an answer to her. How can you be sure that in a survey with thousands of observations, we do not have two observations that are exactly identical? Well, it's not me, the one who has done the math. There are two co-authors, Kuriakose and Robbins, that in 2015 developed a tool to identify duplicate data based on the probability that over a questionnaire of at least 100 questions, a respondent would, two respondents, different respondents, would give exactly the same answers. And the probability that this happens is very, very small. But we will get to Kuriakose and Robbins in a short while. Where do duplicate data come from? Well, there can be many possibilities. The most obvious one is duplicated data come from errors or forgery made by interviewers. This might not necessarily be bad. Imagine that you are running a survey in Iraq or Syria where there is a war ongoing, and maybe there has just been an attack in a quarter of your city. Are you sure you would like to go there and knock at the door to collect the data? I would agree that maybe you sit down and copy the results. There might be a mistake by data coders or by data processing staff. So these kind of origins are normally acknowledged in the literature. What is not acknowledged in the literature is how this affects the estimates. And this is exactly the point of our work. Normally, I'm speaking here about myself. When I open a data set, I assume that the data we use are reliable. I look for missing data, coding, etc. But on average, I think that the data I'm working with are true. The point is that, as Kuriakose and Robbins put it in an article of 2015, non-unique records occur at non-negligible rates. And from this point of view, to the best of our knowledge, there are only two papers that deal with the presence of non-unique records in international surveys. One is by the team led by Professor Słonczyński of the Polish Academy of Science, 2015, who concludes that over a large panel of countries and surveys they consider, we will get to the details in a second, they find that in 17 out of 22 international surveys, there is a considerable amount of duplicates. Kuriakose and Robbins, that got the attention of popular press in 1 or 2 months ago, exactly for this topic, document, thanks to their method, that 20%, that is to say 1 out of 5 of 1,000 public data sets that they analyzed contain duplicated observations. So these two pieces of information convinced us that actually there is more that we need to explore about this topic. And we looked into the details. Słonczyński et al. Put together 1,721 national surveys from 22 comparative survey projects. They put together and harmonized, the project is called Harmonia, you can Google for it. They harmonized data for 142 countries, collecting 2.3 million of observations. So in this data set you will find the World Value Survey, European Value Survey, ISSP, ESS, and much more than that. And they have applied their own algorithm, which personally I don't know, I admit it, to spot the presence of duplicated data. What they find is that surveys with duplicates are frequent. So, analyzing the surveys in ISSP, they found that 35.8% of the surveys contain some duplicated data. 1 every 3. Latino Barometer, 68.4% of the surveys of Latino Barometer contain at least some duplicated data. Word value survey, we're close to 20% of the surveys. ESS, 3.4% of the survey contain some duplicate data. Now let's be clear on this. I'm not saying that 68% of Latino barometer is duplicated. Okay? I'm saying that at least that large majority of Latino barometer surveys contain some duplicates, and this can be very little, even just 1% of the observation, but there are. Indeed, the second point that the Skonczynski et al. Point out is that duplicates are not many. On average, there are no more than 1% duplicate records. 1% on a survey of 1,500 observation means 6. So it's not many, but there are. But sometimes they find 10% of duplicated data, or duplicated records in a survey. 10% on a survey of 1,500 observation is 78 observations. Okay? Examples. Duplicates come with various patterns. In Ecuador, in 2000, Latino Barometer, so this is a survey, they find 60% of duplicate records. This is a lot. And in particular, they find 272 doublets, meaning couples of identical observation, 272. So we are above 500 observations. And 63 triplets, means copies of 3 observations. Alright? Norway, ISSP 2009, 11% of duplicate records. 11%. Doublets are 27. No, 27 doublets. So means 54 observations. 12 triplets, 36 observations. 6 quadruplets, 4th observation 6 times. 5 quintuplets, and more. It was too much to list them all, I cut it. So, from this first study, we came to the conclusion that actually duplicate records are worrisome. But then we looked into the work of Kuriakose and Robbins, that, as I said, received some attention in the international press because 3 papers published on the Journal of Statistics of the American Association, I don't remember now the exact name, raised the attention of the Pew Center, which is, Pennsylvania, a famous research center in the United States that collect data, etc., for which, where Robbins and Kuriakose met, actually, and they the first thought about the method to identify duplicate data. And the Pew Research Center, of course, felt under attack and as replied to them, inviting them to withdraw the paper, and actually they didn't withdraw the paper. So now we have online the paper by Kuriakose and Robbins and the rebuttal by the Pew Center. But what they found is interesting. They analyzed 1,000 national surveys, more than 1.2 million observations, 35 years of surveys, 154 countries, territories or sub-regions. As I said, 1 out of 5 of the surveys have duplicated data. 1 out of 5. 30%, and this is where Pew got angry, 30% of the 309 Pew international studies has duplicated data. In Western countries, this is very important. In Western countries, 5% of the surveys have duplicated data. In developing countries, on average, this is 26%. So this piece of information suggests that actually duplicates are not many, this we know, but also they are not uniformly distributed across surveys. If the survey is done in developed countries, we can be more confident that they are good quality. If it comes from developing countries, we have to be more cautious. And they are the first one who put the attention on the fact that we can deal with near duplicates. So the fact that, as I said, the variables identifying the strata are correct, but all the others are copied. Now, the debate that has come out of this is curious. If you read what has been going on the press on this, it's very strong. Pew uses very strong words against Robbins and Kuriakose. By the way, just for information, Robbins I don't know where is he now, but he used to be the director of the Arab Barometer. And he ran his analysis for the first time on Arab Barometer, documenting this kind of problem, and then starting investigating his own data. And he found that he had some false positives, but he also had some real cases of frauds. So, to summarize the debate of the presence of duplicate data in surveys, I think that the debate is going to look like this for a while. And probably they will never set, they're disputing on whether to, where to set the threshold to identify duplicate data, whether this is independent from the number of variables and observations, etc., etc. I think the important message from this debate is that whatever direction it takes, the problem isn't going to just go away. Actually, the question remains, how duplicate records, independently from how many they are, affect the results of regression analysis and how we can deal with them. So we set up to work on this issue. We decided this is a relevant question, let's address it. How do we do that? Well, we assess the risk of obtaining bias estimates due to duplicated observation. We expect that duplicated data, duplicated records affect our estimates, falsifying our conclusion. Why? Because duplicated data increase the sample used in statistical inference. Simply, they substitute two cases. They reduce the variance, because of course if you have duplicated observations, you basically reduce the variance. Artificially increase the statistical power of estimation. Get to the extreme where all the data set is made of the same observation. You basically are hitting 1,000 times the same point, you have perfect prediction, right? And this would lead to narrower estimated confidence intervals, which, if you are mad for policy conclusion as I am, this might lead you to wrong policy conclusions. There is also another problem that we are addressing, and it is the problem of typical and deviant cases. So far we have been speaking about duplicated data that can be anywhere in the distribution of a variable. But this is not necessarily the case. Duplicated data might be concentrated in specific part of the distribution. They might be in the middle, around the average, for instance, the mean value, and this might have some implications for estimates, like increasing the significance of this kind of estimate, for instance. But it might also be that duplicated cases are present in one of the tails, or both of the tails of distribution, thus representing kind of outliers pushing the distribution in one direction when instead the distribution is not there. So you understand that not only is a problem of, in general, duplicated data, but also where the duplicated data are. And we are taking this into account. Second part of the contribution is what we can do about it. So once we know if there is an error in the estimates due to duplicated records, what can we do about it? The policy conclusion. We assess the reliability of possible solution. The first one, the most simple one, naive estimation. Naive means that we put ham on our eyes and we run regressions. Means that we ignore the presence of duplicated records and we get our result. And we have it. Second solution, drop in the duplicate observations. Hey, I know you're a duplicate, I'm gonna drop you. The problem is, if you have perfect or duplicates, you don't know which one is the original one. What do? You group them all? This has also the downside that reduces the sample size. Right? Okay, if on average we have 1% of duplicates, losing 6 observations on 1500 is not a big problem. But still, it reduces the sample size. Flagging the duplicate observations. I know you're a duplicate, and I make a dummy. And then I make a regression naive, but I add a dummy and I check for this. So at least I don't lose observations. Fourth solution, robust regression. Robust regression is OLS that takes into account the weight of influential observations. So in a way, this should help us downsize the frequent cases, okay? The last solution is waiting for the inverse of the multiplicities. The name is awkward, but the practice it is not. Basically what this suggests is, hey, count how many duplicates you have, and weight each observation by 1 over the number. So if I have 2 observations that are duplicated, each of them gets a weight 1 over 2. Observations that are not duplicated gets a weight of 1. And you run a regression weighting with this. So we check how each of these 5 performs. Of course, our reference point is naive estimation. How do we do that? We don't know. We don't know because we don't know. If you take whatever data set, you don't know if some data are duplicated or not. So the only solution is to build your own data set in a way that it follows some specific patterns. This is why we adopt the Monte Carlo Simulation, which is a way to build up your own data. And this allows us to check how various numbers and patterns of duplicate records affect the risk of obtaining wrong estimates. How do we do that? So we proceed in 4 steps. I'll go slowly. We first generate an initial data set. We assume that we have 1,500 observations. This is arbitrary, but we also think that on average the service with which we work are about 1,500 observations. We imagine we have 4 variables, x, y, z, and t, where y is our variable of interest. We take a matrix of correlation that fixes the relationship among variables in our data set. Now, I don't remember exactly where I took this number from, but for those of you who work with Stata, I am confident that this is the correlation matrix between 4 variables in the auto data set of Stata. Auto is a toy data set with which we do basic stuff in Stata. I think this comes from there. And then, our idea is very simple. We run a regression, y over x, t, and z, and if this is our naive estimate, I mean, in this case we do not have any duplicate, right? So all observations are original. So we want to predict y, and what we are interested in is in getting alpha, beta, beta 2, beta 1, beta 2, and beta 3. And what we want to see is how these coefficients change when we introduce duplicated data into our analysis. Of course, creating a data set is a necessary step for us to keep track of which observations are true and which are not. And also to force the observations to be, the duplicate observations to be either in the overall distribution or in a specific part of the distribution. Second step, and here is where the Monte Carlo comes in. It's a bit crowded, but I'll try to go stepwise. So we duplicate now randomly selected cases. Here is when we want to build, to create our duplicated observations. So we start with 2 alternative scenarios because we are interested in various patterns of duplicate observations. The first one is when one observation is duplicated from 1 to 5 times. So we take one observation and then we duplicate it 1 time, so we have a doublet. We duplicate it 3 times, we have a triplet. 4 times, quadruplet, up to 5. Okay? Second scenario is when data contain multiple pairs of identical records. So here we're taking a doublet and we are duplicating it 1 time, 6 times, I don't remember it anymore, but you will see it later, up to 79 times. 79 doublets, I emphasize, in a sample of 1500 observation amounts to nearly 10%. Okay? So each of these two scenarios is then multiplied for each of these variants, which is when the duplicate records are chosen randomly from the overall distribution, where each of the duplicates are from the second and third quartile of the distribution, so we are in the middle of the distribution. And then we have the left type and the right one. So we do this, apply this scenario to these 4 variants, and this scenario to these 4 variants. 2 times 4 is 8 possibilities. Then each of these variants is applied to different solutions, as you understood already. Naive model, dropping duplicates, flagging duplicates, robust regression, weighting by inverse of the multiplicities. So in the end, we have 2 times 4 times 5 equal 40 patterns of duplicate records that we analyze. And we plug all this into Monte Carlo. Simply, we start randomly selecting duplicate data for each of these cases. And we do this for 1,000 repetitions. Third step, we now have 40,000 data, if you want, and on each one of these we run our regression. When we run our naive estimation, we drop, we flag, etc. Each time we store our coefficients, and we compare these coefficients with the true ones that we had computed at the beginning. Fourth step, we can assess the error. Sometimes you will see bias in the slide, but the reviewer has corrected us, this is not a bias, this is an error. All right. So what we do is we subtract the true coefficients from those estimated for data with duplicates. And we use the F-betas to assess the severity of the error. What are the F-betas? The F-betas are just, some of you are familiar with this, so are just normalized measures of how much specific observation affect our coefficients. They are computed as the difference between the coefficient when you have duplicated data minus the true coefficient over the standard deviation, the standard error of the new coefficient. And the F beta is considered to be high if it is over a certain threshold, which is given by 2 over the square root of the sample size. If the sample size is 1500, our reference threshold is 0.05. This is an example of the many data sets that are produced during our replications. This is just to give you an idea, an intuition of what our data look like. So we have the initial data set, we have a flag, and this, in this case, suggests you that there are no duplicates in our data. We have 1500 observation always, which suggests also that when we have duplicates in our data, the duplicates are substituting real observations, original observations. We run regression on each one of these scenarios. Are you with me? Falling asleep? All right, so just to wrap it up, this is the schema that we have followed. So we have generated our initial data set, 1500 observations. And then we have applied this to our two scenarios, and we have started our replication. So each scenario gets applied to 4 variants, and then to each of these 5 solutions. All right? So it's just a matter of combination. Luckily, our computers are fast enough, so we didn't get too old while getting the results. And finally, we assess the bias, the risk of the bias, of the error. What have we found? When one observation is duplicated 1 to 5 times, so we have one duplet, one triplet, one quadruplet, quintuplet, and sextuplet. So this amounts to nearly 1% of duplicates in our data set. These numbers, what do they mean? These are the value solution. 1 stands for naive estimation. 2, dropped. 3, flat. 4, robust regression. 5, weighted by the inverse multiplicity. And then we have our coefficients, the constant, the coefficient for t, x, and z. All right, is that clear? Well, I understand that you cannot see much in this figure, it's normal. Just notice these 2 solid lines here. This is our threshold, 0.05. And here, in just one line corresponding to each one of our solutions, we have the distribution of the results of the DF betas for our 1000 repetitions.
So these are the estimated betas.
Correct. DF betas. Correct.
Difference drop.
And if you could see these in an enlarged, this is just the box and whisker diagram. And these dots, if you read the box and whisker correctly, are considered outliers. So the question is, how many are outside of these boundaries, right? From this figure, all that probably we could say is that by increasing the number of duplicates, this spread increases. The possibility of making a mistake increases. And I want to emphasize that here we're moving from 2 duplicated observations on 1500 to 6 duplicated observations. So there is not so many duplicates, but we see that there is a level increasing. We can look better into these results by looking at a maybe more human diagram. In this case, it is a bar plot where we have for each of the 5 solutions and for each case considered, what is the percentage of cases that fall within the acceptable range, within that threshold. So, when we have, in the case of the naive estimation, if we have just one single doublet in our data set, we have, let's say, 87% chances of getting good estimates. 87 also means 13% chances of making a mistake. When we move to one triplet, we go down to 68%. Sorry. Quadruplet, 54.5%. Quintuplet, 46.3%. 1% of duplicated, 41.6% of acceptable errors. Which means 42, let's say, because I'm not good at counting, 58% of errors. The good news, if you have duplicated data, my personal recommendation is go for the inverse multiplicities, because in any of these scenarios, there are those that perform slightly better. You will see also in following results. You have very good result in case of just one duplet. In the other cases, it's performing more or less like dropping or flagging. But you will see in the next slide that indeed probably this is the safest option, the fifth. What else? It is interesting to notice that robust regression systematically fails. 29%, 27%, 6%, 5%. The picture is more or less similar when we look at one doublet repeated many times. And here we see how many times. Before I didn't remember. 1 time, 6 times, 16 times, 40 times, 79 times. And here you see why I said if you have a doubt to go for the inverse multiplicity, because in any of these 5 scenarios, it is the one that performs relatively better. Although the news are not so good, because with 79 doublets, you have 15.2% chances of getting the good result, which is really not acceptable. The other solution more or less work poorer than that. So, waiting for the inverse of the multiplicities decreases the risk of obtaining erroneous estimates if one duplet is present. Dropping, flagging, and waiting work well when data have a single triplet, quadruplet, quintuplet, or sextuplet. Dropping and flagging perform poorly if multiple doublets, 1, 16, etc., are included. Robust regression, forget it. Let's look at typical endeavor cases. So when the duplicates are in the middle or in the ties of the distribution. What does happen? Unfortunately, I didn't find any better solution that showed you this table. So I simplified it. We are taking just one duplet, one quadruplet, one sextuplet. The results are more or less the same also in the other scenarios. And what we found is that there is no real pattern. We were expecting that deviant cases, so when duplicates are in the ties, are more influential. But actually, we didn't find a consistent pattern through our replications. We found that, for instance, when just one duplet is present, you see that duplicate overload over the whole distribution. Yes, more or less, you get the same chances of a good estimate in all alternative scenarios. It is less so when you have one quadruplet, where in this case, when you have the duplicated in the two tiles, your probabilities go really low. But you see, if you compare with the center of the distribution, the estimates are then not so significantly different. So, typical Ordelian cases do not make much of a difference. The risk of error when the duplicate is drawn from the overall distribution is not lower than when the duplicates are in the tiles or in the center of the distribution. There, these results are independently from the solution we adopt. And what is interesting is that we have replicated our estimate also when the duplicates are not on the y variable, but on one of the explanatory one, the x. We got exactly the same results. So, concluding remarks. The main and only message that I can give you strong is be aware that duplicate records matter. Look for them. Include them among the list of public enemies. The risk of obtaining wrong estimates increases with the number of duplicate records. A single sextuplet increases the probability of unbiased estimates, as a probability of unbiased estimates of 41.6%. 79 doublets corresponds to a probability of unbiased estimates of about 11.4%. So even a small number of duplicates matter. Don't fear typical endermion cases. They are all bad the same. And only good message I can give you is, in case of duplicates, waiting by the inversion of the multiplicity seems to work best. So, the policy implication. For me, the policy implication is look carefully at the data that you have at hand. Check for fleas. So, it is possible to adopt a solution to minimize the errors, but in these cases, the best solution is to ensure that at the source the data are of good quality, because the solutions that we have, at least at this stage, are not trivial. Thank you for your attention.
Thank you, Francesco, for your, as always, very brilliant and exciting presentation, very entertaining as well.
Thank you.
So now it's question and answers. Yes, Edward, please.
I'm sorry, I don't see anything in this in these classes, so forgive me if I ask the wrong question. But I wonder, how do you make the vector of weights? Because I understood that the weighting is the best solution. So is it simply proportional to the so it's 1 over how many times this record is repeated? This is it.
Yes.
Okay, this is very simple and helpful. Thank you.
Thank you very much. I'll just speak without the mic. Thank you very much. It's really very encouraging, and so thank you.
Discouraging.
Otherwise discouraging. Yes. But it's like really, I'm just now thinking, okay, some bias that I got in my data, maybe. I mean, it's due to bias that some effects occur, really. Well, I would love to ask you, I mean, is it possible just you're having the Monte Carlo simulations within the data, how you created it? What about, I don't know, like, I mean, the data that you created them with simulations, right?
Yes.
What about, I don't know, like, introducing some frauds into some real data? Yeah, on the one hand, you will know that on the one hand the data is initially biased, but you will introduce some more faults and see how different it will be.
Yes, you can do this, but you're starting already from a fake result, and you can just make it more fake. Our point was to start from a true result, a really true result, and then compare it with scenarios where we control exactly the amount and the position of the duplicate observations. Because also if you start with an original data set, let's say a wave of the world value survey, let's say it has some duplicates. First of all, you might have just 6 observations, not that many, or you cannot. I mean, what's the point of starting with an original data?
Or maybe I'll tell you what I see the point, because it also may be possibly creating your own data sets. I mean, with real data, just where you control everything. I mean, like on a very small sample, but sometimes really, I mean, it's like, for example, with some in various tests, if you go to Monte Carlo and then they turn to be somewhat different. I mean, sometimes with simulations, when you are going to real data, it may be somewhat different effects and so on.
What's applying variance test?
I mean, for example, with alignment, I checked that, for example, when you read the papers where the data was created with simulations and so on, and then you are then taking that, using that on your data, these recommendations that were good simulations turn out to be maybe not so good in that case.
So your question is how the presence of duplicated data affects the invariance exercise?
No. I mean, just maybe creating not only a simulated data, but with real data. It would be also interesting just to check it as one more proof of which is the best way.
Well, as a matter of fact, I've done this using the auto data set of STATEC, but we decided not to include this into the paper simply because it seemed that building our own laboratory experiment and manipulating the variables at our will was way more effective. But we'll give a deeper second thought to this and maybe we will include it. I don't know if this answers it.
Okay. Yes, please.
Thank you very much, Francesco. I must admit, I've never thought of it. I thought of fraud or people filling in interviews which you can't actually control for, but this is a very relevant issue, and it's really nice to see how you actually can handle it as well. I have one question which is more clarification and one which is purely using your knowledge on the topic. Do you know whether there is any regional differences in how often these duplicates exist? Seemingly, in less developed countries it happens more often.
Yes.
And so I would also think that perhaps in post-communist countries it happens more often, simply due to corruption and not executing things as they're supposed to be executing. So I wonder whether you know something about it, one. And two, I didn't quite understand, and I apologize, that's pure lack of knowledge here on the year betas. So basically you compose that by subtracting old, I mean the new beta divided by the new beta, which by definition means that you would have the if result.
Yeah, I'm following you.
And So that would be your, say, reference point, and you would subtract the new one from the reference point. That means that you would have n-1, which means 4 observations, and you always presented 5 biases, and I couldn't quite get you there. So, okay, maybe I would ask you that later.
The
Perhaps I don't think
naive, we have 5,
Mhm.
because we have the naive. So
Yeah.
the regression when you have duplicates and you ignore them. But our 0 case is the true one. The one when you have no duplicates at all.
Then it's 6-1.
Exactly. So you have 5.
Thanks.
And for what concerns the issue of duplicates in surveys from post-communist countries, I do not have the number, but it would be easy to check it by looking at the paper by Burakoza or by Somczynski. I can let you know if you're curious. But for instance, as I told you, the ESS, for instance, on average, so ESS now is how many? 7 waves. 7 waves, let's say on average 20 countries. They have 140 surveys. So 3.5% of them have duplicated. It would be interesting to see where they are.
It's a thought. I thought maybe you know I can also.
I think it's also not just, sorry, I think it's also not just only issue like better countries and worse countries. There are also big differences like between like waves, like they're conducted by different institutions. So it's really like issue that is very much related to how specific work is.
Yeah, I can imagine that some waves were conducted in specific periods of time that affected the data collection more than other ways. That makes perfect sense.
It is possible, yeah.
Good question.
Just a second. I want to also I raised my hand. So I mean, I didn't quite understand what is duplicate really, because for some, let's say that some answers are we have very much people give the identical answers for a number of questions, and they kind of true identical answers. It's not fake. It's not somebody fake. I mean, how many of them should be duplicates? Because, for instance, some answers are people tend to really give the same answers, and what is this internal dynamics? What is duplicates? How many of them? And what counts as a duplicates as opposed to true, real, identical answer which are not duplicates? Can you understand what I'm saying?
I hope so. I think.
For instance, you're saying democracy and 90% say democracy, then some similar question, like again 90% really give you the same answer again, and some. Let's will it count for as duplicates in this case? How many? We should say 2. Or it's two answers in a row.
No, these are all the answers.
So every
If you imagine your matrix
yeah.
and you have 100 variables, 2 observations are exactly the same values for all 100 variables.
Oh
The
yes.
probability that this happens are very low.
I'm sorry.
Yes, that's because even if I forge, for instance, I'm interview who forge answer, it's hard for me to really remember all these answers. So probably I would make some mistakes. So basically, do you know I mean how the internal mechanics of really producing duplicates and what counts as if it's just saying that it's the same? Well, I don't know.
Well, the same or near the same as Robinson Kuliakos.
Yeah, I'm near the same. What is near?
I think, well, for instance, if you have the variables that identify the strata, normally those ones are original, because it would be very easy for the PI to check whether you have copied something if you don't respect the strata. So you normally, for instance, age, sex, or region, or township are original, but all the others all the 197 variables may be copied. Now, the question that you're raising probably should be addressed to Kuriakose and Robbins and colleagues, and it is at the center of the debate that there is currently between Pew and them. They are contesting whether the duplicates they identify are indeed duplicate. And on this, I think they will continue arguing for the next 10 years.
Yeah, I remember this slide.
From my point, I'm just making a step backward and saying, independently from how many effective there are, what can we do when we detect some?
Okay.
It's this kind of
Yeah.
our contribution.
Makes sense. Okay. Okay.
Yeah.
Dimitri and
Yeah, so elaborating on your question, you mentioned a sample of 1,000 respondents, right? He mentioned
1500.
1,500.
Our is 15.
Okay, well, you mentioned have different situations. Let's say 1,000 persons in a national sample. And we have, for example, less questions. So if we raise 2 to 10th power, so multiply 2 by itself 10 times, we get 1,024. So we have 1,024 possible kind of profiles. So if the distribution was equal, then there should be no duplicates in a sample of those 1,000 respondents, right? But because there are like, we have 10 questions which are dichotomous, yes or no. And people can answer in one of 2 ways. And all these possible variants end up in 1,024 possible answers. So in a sample of 1,000 respondents, if the distribution is ideally equal, there should be no duplicates. But in reality, the distribution is, in the bell curve. So how, with a small number of questions, a small number of options, and a small sample, how do you differentiate these false duplicates with kind of real duplicates?
Personally, I don't know. As I told you, this is not my point.
Okay.
This is a question for Kuriakose. I know that in the debate they have with Pew is how do you adjust the threshold when you have less questions? But again, this is not my point. My point is, whatever is the number of duplicate, what are the implications for estimates and what we can do with it. So I have no problem with this. I have a data set with 1,000 observations and 3 variables. You happen to find duplicates. First step, let's check if they are really duplicates. So this is a question that we need to raise to the data producer. Second, if you don't have an answer and you want to be sure, go for a naive and go for a weighted estimate. This is methodologically what I could advise you. To be sure that the results you are getting are reliable.
Okay, thank you. Edward?
Sorry for asking a second question, but I want to go back to the practical issue of calculating weights. And it seems very simple and easy to calculate perfect weights for perfect duplicates. It's 1 over the times the case is repeated. But then, have you experimented or do you have an intuition about what to do with partially duplicated cases, that is nearly similar? Would it make sense to do fracture weights depending on the proportion of the variables that are duplicated? Or, I just wonder what you think.
That's a very good question. That's a very good question. An easy turnaround would be if you take out the variables that are used for the strata, then the recipe shouldn't change. You still wait for the inverse. But good practice suggests that you should never leave out the variables of the strata. So I cannot hide myself behind this finger. I don't have an answer. We should probably try with this. Indeed, we didn't contemplate in our study the possibility of near duplicates. We are working with full duplicates. Do you have any?
No, we work on full duplicates. This is the
like this is the first time that we're doing something like that. So like it's first approach and yeah, what to do about reduplicates? I think then perhaps the question is more complicated because then usually there would be like some segments that would be like perhaps like copied from other interviews, and then perhaps you need another way how to like clean this data or deal with this data. What we want to do here is just look at the simplest, most.
That's
But this is straightforward.
That's a very important question, and it raises a methodological problem, because the issue of using the weights is mentioned in the literature, but indeed, I don't think that even theoretically it is applied to near duplicates. We should go back to the book. But thank you for pointing this out. We'll probably next work we should be on that.
Okay, yes, Ryan.
I have a couple of questions. Maybe this will continue what Peter mentioned. Imagine we have not the duplicates but the true identical answers. Given that we do not know, the truth, do you think of any external variable that would help us evaluate the quality of some, of the sample, or something that would control that?
The length of the interview is the most easy one. The problem is that very often we don't have this data. But it's the first thing that I would ask. Show me how much time this interview has taken. If it takes 20 minutes and we know that it lasts 1 hour.
Okay, thank you. Any other? Yes.
Well, it's a really interesting approach to the problem, but I also think about something else, because we are trying to fix our data. And maybe we should make something like policy implication, because first of all, we have different sample designs. And for example, in LCS, where all questions are exactly the same, they use different sample design depending on how good is the experience of organizations that is conducting a survey in a certain country. So we can compare how much duplicate, and we know that some designs are simpler for interviewers and other ones are a bit more difficult, that cause us to duplicate cases. And also I think it's maybe important to compare different organizations, and well, it's maybe different part of such kind of projects and related to quality of work, but still it might be interesting, and maybe you have seen something like that, because I think that some people work well and some are not, and maybe it should be discussed.
Yes, of course. I do agree with you. This is exactly the meaning of this picture. The good data was born when we produce it. And it is when we train the interviewers that we reduce the chance of duplicated data. It is when we select the company that does the survey that we already decide how it is going to be. It is when we choose the period for the survey. It is the responsibility of the PI to be sure that interviewers are doing their work properly, to motivate them. So I think this is exactly the direction, what you were saying. What I wanted to conclude as my policy recommendation is that although we can correct is not easy. The only solution is to prevent in this case. And paying attention at whom we engage, how they work, which kind of output they provide is the only solution that we have to minimize the risk of getting to wrong conclusions.
Okay, thank you. There are any other questions, comments, suggestions?
Very nice one.
Okay,
Very much.
So let's